Okay, we're to our last section of Calculus 1, Section 5.6, Area. Now, you already know, we've already discussed a couple things about area. If f of x is greater than or equal to 0 on a closed interval a, b, then the area bound by y equal f of x in the x-axis on the closed interval a, b is given by area equals the integral from a to b of f of x dx. And so we're talking this region right here. That area equals the integral from a to b of f of x dx. And then if we happen to be below the x-axis, if f of x is greater than or is less than or equal to 0 on a closed interval a, b, then the area bound by y equal f of x and the x-axis on the closed interval a to b is given by area equals the opposite of the integral from a to b of f of x dx. So very similarly, talking about the area of that region right there, that area equals the opposite of the integral from a to b of f of x dx. So, first guy here. Find the area between the x-axis and y equal cosine x on pi over 6 to 5 pi over 6. So pi over 6 is there, 5 pi over 6 is there. And so notice the key thing we have to notice here is that part of the region is above the x-axis and part of the region is below the x-axis. So to find the area on this problem, it's going to take two integrals. One for the top of the one for the area that's the region that's above the x-axis, and one for the region that's below the x-axis, where everything is changing right there. Now, that's the x-intercept, and from what we know about y equal cosine x, that has to be pi over 2. It seems to also look right graphically. However, you're not allowed to interpret x-intercepts, and later when we get to points of intersections, you're not allowed to interpret those things by looking at a graph. Graphs are good estimates and can help us verify answers, but you can't come up with exact answers. So I need to know the x-intercept. So we need to find the x-intercept because that's what distinguishes those two regions. We need the x-intercept to find set function equal to 0 and solve. So in this case, I'm going to solve cosine x equals 0. And then we do know that we're between pi over 6 and 5 pi over 6. So I'm asking myself, between pi over 6 and 5 pi over 6, where does cosine equal 0? And indeed, that is the pi over 2, which looks perfectly reasonable from the graph. So I now definitively know my x-intercept. So let me call that A1 and A2, area 1, area 2. Make that look more like A1. And so the total area will be the area of A1 plus the area of A2. A1, which is above the x-axis, is going to be the integral from pi over 6 to pi over 2 of cosine x dx. And then area of A2, because it's below the x-axis, is going to be the opposite of the integral, pi over 2 to 5 pi over 6 of cosine x dx. And there's the integrals. In this case, they'll do it for us. Now, sometimes on a test, I might say set up only the integral or integrals necessary to find the area. If I say set up only, here's the work I would need to see. I would need to see where you calculated the x-intercept, then I would need to see the integrals. Now this says find the area, so we'll do the calculations all the way out. But the new stuff here is the setup of the integrals. Everything else we've been practicing a long time. Figuring the rest of this out, we've been practicing. Here's the new material. Finding that total area, since part of it was above the x-axis and part of it was below the x-axis, we needed two integrals. The one that's above the x-axis, pi over 6 to pi over 2 of cosine dx. And then below the x-axis, the opposite. Now, of course, on the next go-around, we're going to say plus minus is just subtraction. But there's the setup. Now, actually doing it. So, antiderivative. You're asking yourself, what has a derivative of positive cosine? Yeah, that's right. What has a derivative of positive cosine? And that is sine. The derivative of sine is cosine. Antiderivative, so you're always asking yourself, what has a derivative of? What has a derivative of cosine? That's sine. Evaluated from pi over 6 to pi over 2. And then that's going to be minus, plus minus, minus. Then the same thing, the antiderivative of cosine is sine. Evaluated from pi over 2 to 5 pi over 6. And now let's do some evaluation. Plug in the upper limit, plug in the lower limit, and subtract. Note this is not, do not do sine of pi over 2 minus pi over 6. That's a relatively common mistake, that people just plug both things into the function at once. That is wrong. You want to use the function once for pi over 2, the function once for pi over 6. Then minus parentheses, plug in the upper limit, plug in the lower limit, and subtract. Notice the careful use of parentheses because you're subtracting this entire evaluation. So then keep working it. Sine of pi over 2 is 1. Sine of pi over 6 is 1/2. Sine of 5 pi over 6 is 1/2. Sine of pi over 2 is 1. And so we got 1 minus 1/2 minus 1/2 plus 1. And so that is 1. And so the area underneath, or let's go back to the original picture. So the area of that total region is 1 square unit. So there's our first area problem. And now we're just going to keep doing more and more area problems, making it a little bit harder each time. Okay, next problem. Find the area bound by the x-axis and y equal x cubed minus 5x squared plus 4x plus 20. I have given you the graph. Now, sometimes in the homework you'll be given graphs, sometimes you will not be given graphs. I don't care how you come up with the graphs. No one is expecting you to do all those graphing techniques we did in Chapter 4. It is perfectly fine to use your graphing calculator to give you a graph. Go and use Desmos on the web, get a graph, perfectly fine. Now, what's not perfectly fine, and here's why I suppressed all my tick marks. Like I said on the previous one, that you can't guess by looking at a graph what your x-intercepts are. So the first thing we need here are the x-intercepts, because I'm going to have two regions, one above the x-axis, one below the x-axis, and what's defining each one of those regions are my points of intersection, or my x-coordinates. Not the x-coordinates, x-intercepts. We need the x-intercepts. And just like before, we set the function equal to 0 and solve. So in this case, we got x cubed minus 5x squared minus 4x plus 20 equal to 0. And we are kind of hoping you remember how to solve some of these basic equations. But this is a polynomial equation. The primary method we're hoping you remember for polynomial equations is to factor. For terms, try factoring by grouping. That if it's going to factor, and it's going to factor kind of using elementary means, that's probably how it's going to factor, by grouping. So I pull out the x squared, leaving x minus 5. And out of the next two, since it starts with negative 4x, and I want to end up creating x minus 5, I'm going to pull out a negative 4, which then leaves me x minus 5. And remember, that's the point to grouping, that you should create these identical factors here. And then once you have these identical factors, they serve as a common factor, and so I can pull out the x minus 5, leaving behind x squared minus 4, and then that factors again. And now it's factored and equal to 0, so I can split it up. That's the zero factor theorem we're using. And remember that step of splitting up is only legal if it's factored and equal to 0. And there are my x-intercepts. Now, if I hadn't suppressed the tick marks, you would look at it and say, does that make sense on my graph? And even without my tick marks, that makes sense, that this looks like that's negative 2, 2, and 5. That looks reasonable. So my area is going to be A1 plus A2. The first region, from left to right, goes from negative 2 to 2 of x cubed minus 5x squared minus 4x plus 20 dx. And the second region, since it's below the x-axis, will be negative the integral from negative 2 to 5 of x cubed minus 5x squared minus 4x plus 20 dx. And there are the two integrals that are being necessary to find the area. Now, if it says set up only, here's where you stop. And this would be all the work I would want to see if it said set up only. But it did say find the area, and you're watching this on video, so I can take as much time as I want. We will work it all the way out, at least until I get really bored with it. So I start with my antiderivative. Pretty much in each case, increase the exponent by 1, multiply by the reciprocal of the new exponent. And remember this part right here, that checks by differentiation. And, you know, good habit, if you've got a few moments, check it back to see if it indeed is going to check back. That's an easy little check we can do there. And then this is going to be minus, plus, minus, minus. Same antiderivative, so 1/4 x to the 4th, minus 5/3 x cubed, minus 2x squared plus 20x, evaluated from negative 2 to 5. And now we work on the evaluation. I prefer to work term by term. So it's going to be 1/4, 2 to the 4th, minus negative 2 to the 4th. Plug in the upper limit, plug in the lower limit, and subtract. Minus 5/3, 2 cubed, minus negative 2 cubed. Plug in the upper limit, plug in the lower limit, and subtract. Minus 2 times 2 squared, minus negative 2 squared. And then plus 20 times 2 minus negative 2. So that's the whole first one. Then dropping down, minus. Then doing the same thing, minus parentheses, because I want to subtract the entire thing. So 1/4, plug in the upper, 2 to the 5th, so 5 to the 4th, excuse me. 5 to the 4th, minus negative 2 to the 4th, minus 5/3, 5 to the 4th, minus negative 2 to the 4th, minus 2 times 5 squared, minus negative 2 squared, plus 20 times 5 minus negative 2. And then you do all that fun arithmetic, and here's where I get bored, and I'm not going to go any further because now it is just arithmetic, and I'll leave the arithmetic up to you. And like I said before, arithmetic is not really the point, that if I gave you this sort of problem and I saw all this correct right here, I'd be okay. Now you just do the arithmetic, and you got the answer. Now, one thing I did want to say in my last 15 seconds of this video, when you have a negative number to an exponent, you need to put that negative number in parentheses or your calculator will do it wrong. End of this video.